In order to solve differential equations of the form of a y double dash, which means d2y dx2, the second derivative, plus by dash plus cy equals 0, a, b, c are constants. We've got a homogeneous situation going on because the right hand side is equal to 0. We've got constant coefficients a, b and c. We have a template to be able to go through these 3 or 4 steps that will allow you to actually solve these. So let's go through those. We know that the solution is going to be of the form of y equals e to the kx. Is most likely that will be the case, that you'll have a solution e to the y equals e to the kx. Then we don't know what the value of k will be some constant. So what we do is we find the first derivative of y, dy dx, and the second derivative of y. We sub these values for y, y dash, y double dash into the original equation up here. And so instead of y double dash up here, we can substitute k squared e to the kx, and we've got a coefficient of a outside of that, etc., is equal to 0. You can see looking through there that you've got an e to the kx, an e to the kx, and e to the kx. It is not possible for e to the kx to be equal to 0. So, because no matter what value you've got up there, even if that's 0, e to the power of 0 is 1, you're not going to get a 0. So you can divide right through by e to the kx, and we get a k squared plus bk plus c is equal to 0. So this is a quadratic in k, ak squared plus bk plus c equals 0. We can solve for k using the quadratic formula. So the quadratic formula says k equals minus b plus or minus square root b squared minus 4ac all over 2a. So the quadratic formula we need to know. Identify what b, what a and what c are, and substitute in there. Now, going back to your knowledge of quadratics, there are 3 scenarios. If this is positive, you get 2 solutions, 2 real solutions. If this is equal to 0, you get 1 solution. And if this is a negative, b squared minus 4ac is a negative, you're going to get 2 complex roots to the equation. So we solve for k to find k1 and k2. k1 you can make it as equal to the plus and k2 is equal to the minus. 3 different scenarios to consider. Let's just go through that. If k1 is not equal to k2, you get y equals a e to the k1x plus b e to the k2x. So if you get 2 values for k1 and k2, you can actually just substitute in there for k1 and k2. All right. If k1 is equal to k2, so in other words, if b squared minus 4ac is equal to 0, you'll just get 1 value of k. We say y equals a e to the k1. You only get 1 value, don't forget. So whatever value of k you get, substitute in there, a e to the k1x plus bx. Now, x is important, a bit different to over here. Bx e to the k1x. And the third scenario is if b squared minus 4ac is negative, and we're going to get 2 complex roots. So we can say k1 is p plus iq, and k2 is p minus. So the plus and minus iq will be k1 and k2, and our solution is y equals e to the px. So whatever value of p we work out, a cos of qx plus b sine of qx. Okay, so that would be a solution if we get complex values for k1 and k2. And finally, each of these contained an a and a b. We've calculated the values of k, don't forget. In this case, we've calculated the values of p and q. So if we've got a and b, if we've got initial conditions stated, we can actually find values by substituting in x and solving for a and b. Okay, so that's the template we're going to use, and I'll go through a couple of solutions in the next little bit of work.